Welcome back to week 7, and we're going to get into some of the details of what weather forecasting is and how it works. In this video, we'll cover the main steps and what kind of goes into a forecast and organizing the data, where the data comes from. And then in video 3, we'll talk about the forecasts that are actually made and the types that can be made, and then we'll talk about precision and accuracy. But for now, we'll talk about the steps and what goes into an actual forecast. So first of all, what is a weather forecast? It is a prediction of how the weather may change in the future based on the observation of current weather conditions and comparing those current weather conditions to conditions that have happened in the past. So for instance, we see a hurricane model here. We have studied hurricanes over the years, and weather forecasters and meteorologists have been able to come up with models and ideas for once one of these develops, where is it going to go? How are they going to know who to warn? And this is based on studying this information over the years. So how does forecasting work? Well, it's based on 3 major steps: the collection of data from various sources and organizing that data for analysis, and then constructing a forecast. And we'll talk about that forecast construction and these 3 main types of forecasts in video 3. So how do we gather data? Where does it come from? So the tools that are involved are ground-based stations. You can see these in a lot of locations. Ground-based radar, ships and weather buoys, aircrafts, weather balloons, satellite networks. So we're going to walk through each of these. So here we can see here's a ground-based station on the Oregon coast. We can see some weather vanes up here, arrow vanes. There's a solar panel to provide power. There's also a way to transmit this data to an actual computer someplace else where the data will be stored. We can make observations, so some of this ground-based station information is actually observations made by people. So a lot of the historical data that we have is based off of observations. So some of these other ground-based stations are going to record temperature, humidity, dew point, wind speed, cloud cover, air pressure, so on and so forth. All those weather elements that we've been recording each week at your weather station. And then here's those tools that should look familiar to you from week 1. So we gather data from ground-based stations. All of this information can be compiled into a database, and that data is then shared through various agencies. NOAA, if you are interested in finding a station to see what data is collected and who's accessing it, you can actually see that on the NOAA website, which is pretty cool. You can actually find a weather station nearby that's providing that data, and you can download it from NOAA. So you can get all sorts of great information. So all of these stations are scattered all across the US. That's like a whole bunch of dots across the country where all this information can be collected from. There's also ground-based radar stations, or NEXRAD. So this is these stations that shoot radar waves at through the atmosphere, through the troposphere, to track where precipitation is occurring and what the intensity is, and then how fast is that air and that precipitation moving, what type is it rain, is it hail, and that sort of thing. So it produces images like this. So this data is collected, run through some pretty intense computers to produce these images, and this is all data that's being recorded, and then that information can be used to track where these storms may go based on where it is headed. Maybe this storm traveled in a certain direction, and they expect, well, as things keep going, it might keep going the same direction, or if something interferes, it might veer off. So there's various ways to predict where things might go. So the next thing are ships and weather buoys. Here are 2 different weather buoys that can be anchored off of the coast. Here you can see a research buoy with a small weather station on top. and you can see how it is actually anchored to the seafloor. This is another much larger station with lots of data being collected. These weather buoys not only collect atmospheric data, but they can also collect data for the oceans. So some of these buoys are actually anchored to the ground, and there are some that are called drifters that can actually travel throughout the ocean at the whim of winds and ocean currents, which is pretty neat. And here are a few more. Here's a weather buoy that's actually being worked on right now. You can kind of see how big they are. If I go back one slide here, you can see 2 people working on this weather buoy. So this one is much, much larger here, whereas this weather buoy is a little bit smaller. And then here's a ship that has some weather collecting data on it. This is one of the NOAA ships. There's a pretty cool, I put some links on the course page to some programs where if you're curious about data collected at sea, or if you have a ship that travels around, or you will be on a ship that travels from place to place, you can actually become a volunteer to record data as you're traveling on your ocean vessel, which is a pretty neat program. So they can actually get this data from these huge freight liners that travel across the ocean, so we can get lots of information that way. So this data is going to be collected from these stations and put in through a computer program, a server, to be able to store all that information. You can also use aircraft and weather balloons. With the weather balloons, you're going to have a weather station, a compact, durable station that is attached to this balloon. It's going to float up into the atmosphere and record data as it travels vertically. So these are released pretty regularly. So we can gather data that way. That information that is stored can either be stored in the actual weather station, or sometimes it can be transmitted to a computer station. Also, there's aircraft that will collect data flying through the atmosphere. So here's the Orion or Hurricane Hunter aircraft, and here's a picture of one of these meteorologists and climatologists maybe studying some of that information. There's a great website I posted on the course page that can take you to a link showing you many of the different aircraft that are used to collect weather data. Pretty neat stuff. And again, as you can see, that data is put into a computer system and stored electronically. We also have satellite networks, so huge amount of satellites that are up orbiting the planet. We can see way more information from these satellites. We can access places that are in the middle of nowhere, literally in the middle of an ocean where there's no land-based stations. That's where the volunteer ship log or a ship weather station is very beneficial to this, to be able to have some observations on the actual surface of the Earth and not just from weather satellites. So this is kind of an image that would be produced from one of these weather satellites. So we get all this information, we gather it from all these different sources. So all of these weather stations, they can actually compile them all in one place. They can go through various channels. They may start locally, maybe a local weather station, local National Weather Service station. There's ones in a lot of major cities. And then once they go through those channels, all this information gets kind of filtered through these various agencies and can end up with at the World Meteorological Organization. So this weather data can be shared with all different countries, which is great to be able to help out other countries to figure out, okay, is there a storm coming our way from the US? Is there a major climate pattern or a weather pattern that we need to look for? So after all this data is organized, it's usually organized by place, by the location, and then what specific element is being recorded. And then if it's organized properly, it can be easily analyzed to produce things like surface weather maps, Doppler radar maps, upper atmospheric maps, satellite imageries, metagrams, atmospheric profiles, and climate tables. So to show you some examples, surface weather maps can show you a ton of information. So here we have a weather map that has various weather stations. There's these weather station symbols spread out on this map. These surface weather stations are showing you temperature, pressure tendency, cloud cover, wind speed, wind direction, tons of info. And then using all that data, the pressure, and also maybe satellite imagery to tell you where the cloud cover is, temperature fluctuations over time, they can figure out where these weather fronts are located, what type they are, where the low pressure areas are, where the high pressure areas are. So all sorts of great information can be gained from these surface weather maps. So tons of info shown. Here we can see weather map, surface map that's just showing temperature. Here's a map that's just showing the general pattern where highs and lows are, where the areas of different types of precipitation are, where there might be weather warnings, and where some of the weather fronts are. And then here we have just a pressure map. So these surface weather maps can show you tons of information, or it can be isolated to specific weather elements. And then we can also see Doppler radar maps if you want to see if there's precipitation coming. This is usually what you look for. So there's a few different types here. We've got this top one. This is a radar mosaic showing exactly where those cloud cover and precipitation areas are located. Here we can see a composite image showing you both the Doppler radar information and also the cloud cover from satellites as well. And we can also produce upper atmospheric maps. So if we look here, this weather map here is showing you what the conditions are at a surface that is a certain distance above the Earth's surface. And usually it can be done by elevation. It can also be done by pressure surface. So they take the map and they produce a map that is just at a specific pressure in the upper atmosphere. These are the conditions that are present. So upper atmospheric maps show you what's happening way up high, versus surface maps that are showing you what's happening on the Earth's surface. We can also use satellite imagery. Oftentimes it is used as a composite of multiple things together. Infrared, isobaric maps can be plotted on these as well. Sometimes if you're interested in just the visible satellite imagery, you can just look at what the cloud cover is. And if you want to add on a composite showing you the precipitation areas and the intensity, you can do that as well. And here's an example of just a satellite image showing you the cloud cover alone. And you can see some of these cyclones that have developed in the tropics. We can also produce metagrams. These are graphs showing the change in elements over time. So we can look at it over a single day. Here, these graphs should look familiar. We have outside temp in blue, dew point is the lower one in red. So we can look at it over a day span, we can look at it over a week, or we can look at it over a month. So it can, or over a year. So it can vary depending on what information you want to gather and how long you want to look for. So you can produce this information from any weather station. These came from the local weather station in Hood River that we were using in lab. You can also look at rain data, humidity graphs. I made this graph myself, taking data from a local weather station and then putting it into Excel to graph what the humidity was like over a day. You can also look at wind speed direction as well. You can plot that on a graph. And here are some metagrams, or mediagrams, however you want to pronounce that, of a certain area. This is Urbana, Illinois, and here you can see lots of information produced. Here we see temperature, looks like dew point as well. We see precipitation, we can see weather, wind speed and direction as well. We can see air pressure, and we can see visibility. All sorts of information can be produced from the from weather data into these graphical representation. You can also look at atmospheric profile. So this is often gathered from weather balloons as they travel upwards in the atmosphere. It will record all this information and produce these graphs. So these are two different graphs from the same location, showing different time frames, so 6 a.m. versus 6 p.m. and things have have changed significantly from one place to another. Here we have a layer in the atmosphere that prevented snow from reaching the ground, and then by 6 p.m. The atmosphere became saturated, and they had snow falling. So this, you can see, shows all sorts of information as well. Not only humidity and temperature, but also wind speed, direction, pressure, kilometers above the surface. So these atmospheric profiles can show you a lot. If we collect data over a significant time period, we can gather data to produce climate tables. This is a climate table for Baghdad, Iraq. So this is information over a year period, telling you the average monthly high, average monthly low, warmest ever, coolest ever, average dew point, precipitation for each month. So we can produce these climate tables for any location that's collecting this data over any length of time. So that's the information that's collected, the steps that go into some of the main steps in creating forecasts. We'll come back and talk about the actual forecast creation in the next video.